Imagine a seasoned mountain climber in the Himalayas preparing for an expedition. They don't just walk up the mountain blindly. They study the weather reports for weeks, check their oxygen levels, and map out every potential crevasse before they even lace up their boots. That is the heartbeat of risk based thinking. In the world of ISO/IEC 42001, we apply the same rigorous, cautious logic to artificial intelligence. The standard defines risk based thinking as an approach where an organization determines the factors that could cause its processes or its AI management system to deviate from expected results and puts controls in place to minimize negative effects. In simple words, it means you stop guessing and start anticipating where things might go wrong before the code ever hits a production environment. Instead of waiting for a disaster to force your hand, you look ahead and ask, what if? You have probably seen this at the office, where a team launches a new complex feature and just prays it doesn't crash the server. Risk-based thinking replaces that desperate prayer with a documented, tested plan. It is about shifting your professional focus from firefighting, which is expensive and stressful, to fire prevention, which is efficient and sustainable. So, now that we have mastered the core philosophy of proactive risk management, you might be wondering how we actually identify these hidden dangers before they impact our business operations. Well, that brings us right into our next step, which is the process of identifying AI risks. Think about a major retail chain in Mumbai that uses AI to manage its inventory across hundreds of outlets. They suddenly discover that their algorithm is heavily biased toward ordering winter clothing for a store in a tropical zone because it was trained on historical data from a completely different region. This is a classic example of model drift or bias risk. Identifying risk is the act of recognizing what could go wrong before it actually damages your brand. The standard requires us to create an environment where we constantly hunt for these vulnerabilities. It is not just about checking the code for bugs. It is about questioning the data, the human interaction with the system, and the external environment. If you are a developer or a project manager, you need to sit down with your team and play the what if game. What if the data source is poisoned? What if the AI model gives an output that leads to a safety breach or an unfair decision? You have to be creative and cynical here. It is like being a detective. You look for the tiny cracks in the foundation before the walls start to crumble. If you don't list the risks in your register, you simply cannot manage them. So, now that we've mastered the art of spotting potential threats, you might be wondering how we decide which of these risks actually deserve our limited time and resources. Well, that brings us right into our next step, which is risk assessment and prioritization. A financial firm in New Delhi identifies a list of 50 potential risks for the new AI-driven loan approval tool, ranging from a minor server delay to a massive data leak that could lead to crippling regulatory fines. They obviously cannot fix all 50 at once. They have a business to run. They must perform a risk assessment. Formally, this is the process of calculating the likelihood of a risk occurring and the potential impact it would have if it did. Put simply, it is a calculation of how likely is this to happen multiplied by how bad will it hurt the company. You use a matrix or a scoring system to sort them by severity. The data leak goes to the top of the pile because the impact is catastrophic, while the minor server delay stays at the bottom. This is where many teams fail. They try to treat every single risk as an emergency, and the team ends up burned out and exhausted. You need to be cold, analytical, and objective. If the risk is highly likely and highly damaging, that is your primary target. By prioritizing, you ensure your best people are working on the biggest threats. So now that we've mastered how to rank our risks, you might be wondering how we actually deal with them once they are on our radar. Well, that brings us right into our next step, which is risk treatment options. You are running an AI project for a logistics company in Chennai and you have identified a significant risk. The AI might misinterpret route data during heavy monsoon flooding. Now you have 4 distinct ways to treat this risk. You can avoid it by not using the AI for that specific route. You can transfer it by using a third-party service that takes the liability. You can mitigate it by adding a human in the loop to verify the AI's route suggestions, or you can accept it if the cost of fixing it is higher than the potential loss. That is the essence of risk treatment. It is about picking the right tool for the job. You have probably seen managers who try to mitigate every single risk with expensive, over-engineered software, even when avoiding the risk would have been free and more effective. You need to be strategic. It is not about spending more money. It is about choosing the smartest response. When you document these treatments, you are essentially creating a shield for your organization, proving to stakeholders that you have thought through every contingency. So now that we have mastered how to choose the right strategy for each risk, you might be wondering how we ensure these treatments are actually working in the real world. Well, that brings us right into our next step, which is implementing controls. Imagine a healthcare facility in Pune that decides to mitigate the risk of AI-generated diagnostic errors by implementing a mandatory review process where a senior doctor must sign off on every single AI output before it reaches the patient. This control is a crucial checkpoint. Controls are the actual measures, policies, procedures, or technical patches that you put in place to manage the risk. If the treatment is the strategy, the control is the action. This is where the audit gets real. As an auditor, I don't want to see a plan on paper. I want to see the control in action. Is the doctor actually checking the AI output? Is there a digital log showing the review took place? If the control is just a note in a policy book that no one reads, then you have no control at all. It must be integrated into the workflow. It should feel like a natural part of the job, not a painful roadblock. The best controls are the ones that make the process safer without making it impossible to perform. So, now that we've mastered the implementation of these safety checkpoints, you might be wondering how we ensure that our risk landscape remains under control as the AI learns and evolves. Well, that brings us right into our next step, which is continuous risk monitoring and review. A tech giant in Kolkata builds a complex AI system and performs a brilliant risk assessment. But then they file the report in a dark cabinet and never look at it again. 6 months later, the AI has evolved, the input datasets have changed, and the original risks are completely outdated. This is a fatal mistake. Risk management is a cycle, not a one-time project. You must continuously monitor the performance of your AI and review your risk assessment as you learn more. It is like driving a car in heavy traffic in Kolkata. You don't just look at the road once when you start the engine. You are constantly scanning, checking the mirrors, and adjusting your speed based on the changing environment. In ISO 42001, we expect to see evidence that the company is actively watching the AI and updating its risk profile. If you are doing this, you are not just compliant, you are resilient. You have transformed from a team that hopes for the best into a team that actively ensures the best. You have successfully navigated the entire risk life cycle, from spotting the danger to building the shield.